Hi, everybody. In this lesson, we're going to be learning about the normal distribution. That's what this week is all about. So, the normal distribution is the foundational thing that connects us from probability into our study of statistics. And the normal curve is actually something that's going to follow us for the entire time we study statistics. If you take statistics next year in AP Stats, the normal curve will be with you in September and it's going to follow you all the way through the end of the year. So the normal curve, what we're doing right now is just getting a good introduction to this statistical idea that kind of represents the foundation of a lot of the statistics that we're going to be doing for the rest of this course and whatever statistics you see in your future. So, and I hate to break it to you, you will see statistics in your future. So use this time to get a good foundation so that going forward, you'll say, oh yeah, I remember I learned about this way back when during the coronavirus pandemic. So before we start talking about the normal curve, let's just talk about distributions in general. So when I talk about a distribution of data, a histogram of data, or a dot plot of data, there's a couple things I can describe about it. I can describe the shape, and there's kind of three variations of shape. So my distribution, my data could look something like this, where there's a lot of low values, and then there's a very few high values. So this shape here is called skewed right. And we're not going to work with a lot of skewed right data. But if you're working with like the value of homes in Cornwall, so let's say I was looking at all the values of homes in Cornwall. A lot of them are going to be kind of in this like lower range, and then there's going to be a couple that the more expensive homes. There's not many of them, but there's a couple of them that kind of give this distribution a tail out to the right. So that's why it's called skewed to the right, because this distribution has that longer right hand tail. So some things in the world tend to have this skewed to the right distribution if there's a very few higher values. Home prices or salaries in a big company tend to have this shape because there's a few people making a lot of money or a few homes worth a lot of money, while the rest of them are kind of on this lower end. Another shape, if they're skewed to the right, you betcha they're skewed to the left. So this is skewed to the left, or skewed left, because the left tail is longer. So when I give a test, I hope I get skewed to the left distributions, because that means a lot of people did well. There's a lot of high values, but that means there's only a couple few stragglers. Hopefully no stragglers, not you guys. There's a couple few stragglers who didn't do so well in the lower end. So when I give a test, I hope I have a skewed left distribution, because that means a lot of people did well and a few people didn't. But the shape we're going to care the most about is things that are approximately symmetric. Things that are approximately symmetric are what we're going to be focusing on. There's a couple low values, there's a couple high values, but most of the people are in this middle here. And this is going to be the shape of distributions we're working with during this unit. Is we're going to be working with things that are approximately symmetric, and the normal distribution is symmetric for that sake. So these skewed shapes exist, but we're not going to really talk about them. We can describe the center of these distributions. And in ninth grade, you guys learned about we could describe it with the median. That's the middle number, right? The middle 50%, what cuts the data in half. Or the mean, which is the average. We're going to be talking about the mean a whole lot. So the mean is simply the center. It's the average of the data. It's the balancing point of a distribution. So the mean is what we're going to be using to describe the center of our distributions. The mean, the average, the mean is the average of the values, is what we're going to use to describe the center of these distributions. That one you know. The spread is going to be a little bit new. The spread measures variability. The spread is a measure of variability in our data. So when we look at data, it's all not just the same number. There's variation, there's variability in the data. If we didn't have variability, well, we wouldn't have statistics. The data would be boring. So there's spread. My data's spread out from that mean. Not everyone is average. There's some people above average, there's some people below average. But that's what we're talking about when we talk about variability. The way that we measure this variability is this value called the standard deviation. So it's the standard deviation. And what this value represents is your typical distance from the mean. The typical distance I am from the center. On average, how far am I from the average, the typical distance from the mean? So we're going to be using the mean and the standard deviation to work with this distribution that's called the normal curve. So the shape that we're going to be looking at is called the normal distribution. Its center is called its average, and the way that we measure the spread or the variability in this distribution is called the standard deviation. So what I have for you here is a standard normal curve. So notice that the shape of this distribution is perfectly symmetric, and it's this kind of bell-shaped curve. It's this mound, this singular mound-shaped bell curve. That shape is the normal distribution, and we're going to be drawing a lot of them. We're going to be drawing a lot of this shape here. A lot of mine end up looking like the Snapchat ghost, but that's okay because it's just going to be a sketch. So of this is the standard normal curve. Why is it the standard normal curve? Well, because the mean is 0. It's centered at 0. This is the center. This is the mean here. The mean is centered at 0, which means, what does that mean? That means 50% of the data is on that side, and 50% of the data happens to be on that side because it's in the center. It's that mean value there. And the standard deviation is 1 unit. So 1 unit, these numbers down here, is how many standard deviations I am from the mean. I am 1 standard deviation above the mean. I am 2 standard deviations above the mean. I am 3 standard deviations above the mean. So this 3 here means I'm at the mean, but I added on 3 standard deviations to get that far. I did 3 jumps from the mean. So the way that this normal curve represents is it kind of represents data from large populations where such as the height of men in the United States will follow this normal curve. SAT scores follow this normal model. Lots of things where you're taking them, the weight of a fish follows this normal model because overall kind of the way that the world works is you get a lot of people who are average, you get some people who are really high, and you get some people who are really low. So what we're going to talk about first is kind of some normal curve basics. The basics of the normal curve. If I'm go from -1 standard deviation, so if I go 1 standard deviation below, so 1 standard deviation below to 1 standard deviation above. So there I am. I went down a standard deviation from the mean and up a standard deviation from the mean. How much of this curve have I used up? 1 standard deviation means I've used up 68%. Approximately 68% of my population, the proportion is 68% that falls within 1 standard deviation from the mean. So let's say the average was 20. I won't go into that actually. So 2 standard deviations from the mean. If I go from the mean, if I go down 2 standard deviations and up 2 standard deviations, if I have all of this here, that's capturing pretty much a lot of the distribution. And this is going to be a big one. That captures 95%. So if I go within 2 standard deviations, from the mean, that captures 95% of the data. We're going to be using this the rest of this unit. So remember this, 2 standard deviations is 95% of the data. And then if I go 3 standard deviations from the mean, so I subtracted 3 standard deviations from the center, and I added on 3 standard deviations from the center. I'm capturing 99.7% of the curve. So I'm getting pretty much everybody. So 3 standard deviations from the mean is pretty much everybody. You have some people out here in the tails, but they're really, 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 really unusual occurrences to end up all the way out here in the tail like that. So 3 standard deviations from the mean basically captures everybody. So if someone told you their height was 4 standard deviations above average, there's no way that I can tell you that person's pretty much lying, because no one's height, there could be someone. Now I'm sure there's some giant person out there, but there's like one person. There's not like 20 people. If you told me I was meeting someone whose height is 4 standard deviations, even 3 standard deviations above the mean, I'm going to say that's not likely to occur. So 1 standard deviation gets you like a middle chunk. 2 standard deviations is the big one. It gets you that middle 95% that we're going to be working with later on. And then 3 standard deviations from the mean captures pretty much everybody. So that's how we work with this normal curve. We're going to be finding what percent of the curve am I capturing? So let's do a question right here. Use technology. So that's kind of some basics, but we don't always have perfect 1 standard deviation from the mean, 2 standard deviations from the mean. Sometimes we're like 1.67. So right here, find the proportion of the population that is more than 2.63 standard deviations above the mean. So I'm going to draw my normal curve. Oh, that's way too big. I'm going to draw a normal curve. Zero's in the center. And I want to be more than 2.63 standard deviations above the mean. So I'm above the mean, 2.63, right? And I want to know what proportion of the population is bigger than that. So there's kind of 3 steps to drawing a picture. You label your center. You label how many standard deviation. What's the important number? 2.63. And that was above the mean, so that's on the right. If I was below the mean, that'd be on the left. And I want to be more than, so I shaded up. So I want to know this proportion. And the way that we're going to get that is from our calculator. So on our calculator, we're going to hit second vars. Second vars brings us to our distributions. And you can see the first 3 choices have to deal with the normal distribution. We're going to use choice 2. We're going to use the normal CDF function, the cumulative distribution density function. We're not going to ever use PDF. We're always going to use normal CDF. If you have a TI-84, you're going to see these prompts. The lower. How low do I want to start counting from? Well, I want to start counting from 2.63. How high up do I want to go? Well, do I ever want to stop? No, I want to go on forever to all the way to infinity, right? I want to keep on adding up forever. So the way that we're going to do that is we're going to type in a really big number, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0. Doesn't matter how many zeros you get. As long as you have a couple zeros, you're good to go. And you're going to enter, 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 enter. Enter, and then enter one more time. That's your proportion. So 0.00437. So how much did I shade here? 0.004342. I know my numbers, that's a 2. 7. So less than 1% of the population is above 2.63. That's how our technology works. So for those of you on, we'll get to Desmos later. I'll make a different video for Desmos. I'll just focus on the TI-84 right now. My 83ers, you don't have that nice little stats wizard, so let me just show you what yours looks like. When you hit second vars, normal CDF, you're not going to get that nice menu. Yours goes low. How low do I go? How far to the left? 2.63. Comma, how far to the right do I go? Well, I want to go on forever. So 1000000. I only did less zeros this time, but that's okay. Close it and you're done. You get the same answer. So this normal curve here kind of lets that normal CDF finds the area under the curve for us. It finds us how much of the curve am I using up in this shaded region. Normal CDF, it's in second vars. Second vars brings you to normal CDF. Find me the proportion of a population that is less than 1.5 standard deviations below the mean. A little typo there, below the mean. So let me draw a normal curve. The mean is here at 0. Find me the proportion of a population that is less than 1.5 standard deviations below the mean. So I'm 1.5 standard deviations, negative 1.5, because I'm below average. I'm negative 1.5 standard deviations from the mean. And I want to be less than that, so I'm going to shade down forever, all the way to negative infinity. So we're going to go to normal CDF. We're going to hit second vars, CDF. Let me turn my stat wizard back on because most of you have 84s. And if you don't have an 84, download the program. Download the program there. So, come on, Sparky. Second vars, normal CDF. How low do I want to go? Well, let's look at our picture. That's why we drew it. How low do I want to go? Negative infinity. Negative infinity. What's my upper bound? How far up do I want to go? I want to go to negative 1.25. Enter, 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 enter one more time, and there you go. What percent of the population? So I'm going to go 10.106 is what that rounds to. So about 10.6% of the population falls in this region. This is 10.6% of the population. Find me the proportion of a population that falls within 1.4 standard deviations below the mean and 1.87 standard deviations above the mean. Well, here's the mean. I want to be within 1.4 below, negative 1.4, and 1.87 above, 1.87 above. So I want to know what's this region here. What's that probability that I find someone in that region? So we're going to go second vars, normal CDF. And I like these problems because how low do I go? I go negative 1.4. How high do I go? I go to 1.87. Enter, enter, enter. And I captured 88.85. So this shaded region here is 0.8885, about 88.9% of the population. I got a lot of people in there. Okay, so that's how we use our calculator to deal with these normal curves. I'm going to be telling you values, and then you're going to have to figure out what's the proportion, what's the probability I find someone who has that given information. You don't need to memorize the 68, 95, 99.7. You don't need to memorize that because you can just use your calculator. How many are within 2 standard deviations from the mean? From negative 2 to 2, right? That's what I did in that important one there. You get about 95%, about 95.4% of the population. So 2 standard deviations, negative 2 to positive 2, is about 95%. So what we're working with here is actually this thing called a z-score, a standardized score. This is my standardized score here. And the way that we define a z-score is how many standard deviations am I from the mean? A z-score is how many standard deviations am I from the mean? So there's a little formula we're going to use a lot in this lesson and the next. A z-score is, well, how far am I from the mean? So I'm going to find the difference. How far am I from the mean? But I want it in terms of standard deviation. So I'm going to see how far am I, but in terms of that number, the standard deviation. So the price of printers in a store has a mean of $240 and a standard deviation of $50. The printer you eventually choose costs $340. What is the z-score for your printer? Well, what does z equal? How do I compute a z-score? How far am I from the mean? 340 minus 240. How far am I? Divided by the standard deviation. So I'm going to divide by 50. Use the fraction button here, folks. Use the fraction button, or just type it in 2 steps. 340 minus 240. I hope you don't need a calculator for that. Enter, divided by the standard deviation of 50. So I have a z-score of 2. That means my printer cost is 2 standard deviations above the mean. That's what a z-score is telling us. We've been working with z-scores. These numbers down here are z-scores. When we use the normal CDF button, we go lower z-score all the way to the higher z-score. The normal CDF function uses z-scores. So Ashish's height is 63 inches. The mean height for boys at his school is 68.1. So right now, I know Ashish has a negative z-score. He should have a negative z-score. Why? Because he's below average. He's below the mean. And the standard deviation is 2.8. What is Ashish's z-score? Well, how do I compute a z-score? Value minus the mean. 63 minus 68.1. The value minus the mean, in terms of, though, I don't care how many inches he is away from the mean. I care about in terms of how many standard deviations he is from the mean. So I find the difference. 63 minus 68.1. That's how many inches he is, but I want it in terms of standard deviation, so divided by 2.8. How many standard deviations is he below the mean? About 1.82. Negative 1.82. So Ashish's height, that's a fun name to say, Ashish's height is 1.82 standard deviations below the mean. His height, that's how I get a z-score, value minus mean over standard deviation. His height is 1.82 standard deviations below the mean. And z-scores are what we're going to use going forward in the next lesson when we work with normal distributions, when we work with these normal curves. So working with a normal distribution, compute the following probabilities. What's the probability my z-score is less than negative 2.85? So I'm 2.15 standard deviations below the mean. There's my z-score, negative 2.15. And I want my z to be smaller than that. I'm going to shade that way. What is this probability here? The normal distribution is what connects us from probability into statistics. So how do I do this? I'm going to do normal CDF. This probability is normal CDF. How low do I go? Negative infinity all the way to negative 2.15, right? How low do I go? Negative infinity all the way to negative 2.15. So here we go. Second vars, normal CDF, negative infinity all the way to negative 2.15. What's that probability going to come out to be? 0.0158. So this probability equals 0.0158. There's about a 1.58% chance that I find someone whose z-score is smaller than negative 2.15. Well, let's look at this next probability. What is the probability that my z-scores trap between these two numbers? So let's draw a picture. That's kind of Snapchat ghost-like. So my center is 0. I want to be between 1.67 standard deviations above the mean and 2.25. So I want to know, and I'm between those two values. There's my lower, there's my upper. So I'm going to do a normal CDF of lower, 1.67, all the way up until 2.55. Enter, 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 and there you go, 0.0421 equals 0.042 about. So there's a 4.2% chance I fall between 1.67 and 2.25 standard deviations above the mean. Drawing the picture is essential here, folks. And finally, last one for this lesson. I draw my normal curve. I want to know the probability that z is bigger than negative 1.2. What's the probability my standard deviation is bigger than 1.2, negative 1.2 standard deviations below the mean? I'm adding all the way up to here. I'll get the galaxy pen out for this. What's the probability I go all the way up there forever? What's the probability my z is bigger than that? Well, there's my lower bound and there's my upper bound. So one last time here. Second vars. Normal CDF. Lower bound was negative 1.2. And the upper bound was infinity. Enter, enter, enter. 0.885. So the probability here equals 0.885. There's about an 88, I hate the galaxy pen. There's about an 88.5% chance I fall in this shaded region here. Okay, so the key thing for this lesson, there's two takeaways. How do I compute a z-score? Well, it's whatever number I give you. How far away is it from the mean in terms of standard deviation? How many standard deviations am I from the mean? And working with a normal curve, you can find a probability or a proportion by using normal CDF. You get your lower z-score, z lower, and then your z upper. You have your low z-score and your upper z-score. Sometimes they're infinity, like we saw here. Sometimes it's negative infinity, or sometimes I give you two numbers. But this is what we learned in this lesson. How do I work with my normal distribution? Well, I use my normal CDF button. And how do I work with z-scores? There was a lot in this video. The next video is kind of just going to be practice problems and using real-world applications of our normal curve. And I'll see you in that video.